Sometimes when we're discussing different types of compounds, we may come across something that does not appear on the periodic table. For example, in this compound, we have a sodium ions, 2 sodium ions actually, that's on the periodic table. But then we have as our nonmetal SO4. Now there's no SO4 on the table. This is actually a combination of several different nonmetals. And in this case, we have what is called a polyatomic ion. Well, what is a polyatomic ion? Well, just as the name suggests, poly meaning many, atomic meaning atom, and ion meaning charge. So these are several bonded atoms that come together to make a single particle with its own charge. It is several bonded elements or atoms that come together to make a single particle with its own charge. In this case, this is called sodium sulfate. Sodium sulfate. So the sulfate ion looks like this. It's 1 sulfur, 4 oxygens, and as a whole thing it has a charge of -2. When we balance and write compounds with polyatomic ions, we have to be a little bit careful. For example, let's look at the compound calcium hydroxide. Calcium hydroxide. So we would start just like we normally do, writing the first element, calcium, and its charge is +2. Notice there is no Roman numeral here because calcium is a group 2 metal. We don't need to indicate what its charge is. And hydroxide is OH -1. OH -1. Many of these polyatomic ions you're going to see over and over again, but what I'll give you in class is a chart that you can refer to with the names and charges of these ions, so don't worry about memorizing them. So let's balance this compound. We know that the calcium, the multiples are +2, +4, and so on, and for the hydroxide we have -1, -2, and we have our lowest common multiple at 2. Let's write our compound. So our compound is 1 calcium and 2 hydroxides. I have to be extremely careful here. If I put my 2 right here, I end up with a problem because this says in my compound I have 1 calcium, 1 oxygen, and 2 hydrogens. But that's not what I needed to do. I needed to say I have 2 hydroxides in my compound. So the way that I indicate that I don't just have 2 of this last atom, I have 2 of this group, this polyatomic ion, is that I put parentheses around it. So I'm going to put my polyatomic ion in parentheses, and that means this 2 goes with the whole hydroxide. So this says I have 1 calcium and 2 hydroxides. Another one we can look at is, let's say, magnesium. Magnesium nitrate. Magnesium nitrate has this formula. MgNO3. Now I have to put a 2 because if I balance this it would be MgNO32, but now this looks really weird. Now it looks like I have MgNO32. NO32 sounds kind of strange, and that will remind me that my polyatomic ion, if I have more than 1, has to have parentheses around it. Here's a chart that contains several common polyatomic ions. Some of these we've shown you. So here's the hydroxide ion. Here is the sulfate ion. Here's the nitrate ion. Notice that all of these, or almost all of these, add in endings other than "ide." Ate, ite. So you know when you hear the names of these polyatomic ions that they are polyatomic. They are not the single atom anions that you normally see that end in "ide." Now there are two, and you can see them on here, that do end in "ide. Hydroxide, which is a combination of hydrogen and oxygen, and cyanide, which doesn't sound like any of the elements on the table. So just remember that cyanide and hydroxide end in "ide, all the others don't, and that's how you know you have a polyatomic ion. The other one to look out for is ammonium. Ammonium has a +1 charge, and it is the only polyatomic cation that we will work with in this class. So if you have a compound with ammonium, just remember that it will take the place of a metal ion. It acts like a metal ion. So if I have the compound ammonium chloride, the formula would be NH4Cl. So the metal, the positive ion, is the ammonium, and the negative ion is the chloride. If I had one compound where I had more than one ammonium, I would have to put it in parentheses. So for example, ammonium sulfide would look like this. So ammonium is the only polyatomic cation that we'll talk about, but you will become familiar with most of these, and all the other naming rules are the same. So you just say the name of the ionic compound, compounds like you would before, but instead of saying your chloride or sulfide ending, you would do your nitrite, nitrate, chlorate, perchlorate, just the name of the polyatomic ion.